Okay, I think we'll start today. So, welcome everyone to our first of the series of seminar in advances in computing. I'm happy that we have first speaker from our own computer science department and AI Institute. So, this is Professor Biplav Srivastava, and today he'll be talking on doing AI research at the time of or at the age of ChatGPT. For those who are not familiar with Professor Biplav, so he joined our school and the AI Institute a couple of years back, and he is a distinguished ACM scientist. He has worked in industry for more than 2 decades. He's a senior Leshner Fellow, senior member in IEEE and AAAI. So his research is on AI for society. Broadly, that's his theme of his research, and he directs a group here. So I give this floor to Professor Biplav, and we can hear what he has to say on this topic.
Sure. Thanks, Vignesh. And welcome everyone to Friday and this semester. How many of you have heard about ChatGPT? Almost everyone, right? Okay, so it's interesting that within a short period of about 8 to 10 months, right? Not only students, researchers, but their grandmothers and parents and everyone knows about ChatGPT, and they know something about what to do with it. Okay, so today what I'm going to be talking about is how ChatGPT has changed computer science, AI, and research itself. Okay, so here is the plan for the afternoon. We'll talk. I'll briefly introduce what I do, and then talk about AI chatbots and large language models, which is what an example of what ChatGPT is referring to. Then I'll touch upon 2 lines of work. One is on core AI task of plan generation and how we are using large language model. The second thing is application of this. Okay, and we'll consider 2 examples. One is in finance, one is in water. We are engaged in a number of areas, including applications in elections and design, physical design, size here, and many other things. Okay, and then we will discuss on how ChatGPT is useful. Usually, it's a very good baseline with which we can start, and how do you work with LLMs? What are the issues and things like that? Okay, and for people who are new into computing, most of the wisdom of computing and technology and business you can get from Dilbert and such cartoons, so you should see them frequently. It came out with something on ChatGPT before Dilbert got shut down. So this is a very brief on what I do, and on the left-hand side, I focus in AI theory on neurosymbolic methods, meaning at the intersection of neural and symbolic methods. This will become a little clearer as we go. Then on usability, which is how do you use AI with confidence? So things like how do you do experimentation, and we have come up with some ideas about how do you communicate behavior, trust behavior, and then applications and things like water, energy, and so on. Okay. And our main aim is to actually promote a vibrant research culture around AI, and some of the things that we are trying to go after. It is not just technical, but also soft skill, thoroughness in work, clarity in communication, proactive focus to complete the work, and comfortable yet working with others. I always try to put this in because this is from industrial experience. What am I trying to do different? So I just wanted to give you these thoughts. And a little bit about the AI Institute itself. It is an institute here on campus. It's supposed to be working with all the colleges across the university, and here is a sample of them with which we are working. we work in a whole bunch of areas, including collaborative AI, which is chatbots, in big data analysis, in trusted AI, theory and applications, and the ones in green are the areas in which I work in. Okay. So please feel free to stop me at any time for any question, clarification. Now I'll quickly go through AI, chatbots, and foundation models, okay, to get to the theme of the discussion. So I'm going to assume that you know somewhat about AI, and for the purpose of this talk, we will assume that it is meant to provide us intelligent agents or software which can help us in making decisions. So there are two broad set of techniques by which intelligent agents are built. One is through machine learning methods, and a whole bunch of examples are given, and through rule-based symbolic methods. Again, a bunch of examples are given. So for example, optimization is a form of symbolic manipulation, and a deep learning model or perception of identifying objects in an image, that is usually done through machine learning methods. So given a whole variety of methods, there are certain limitations of these methods. One of them is generalization. They are good at solving one task, but not a whole range of tasks. They are very resource intensive, and what you want is they should take less memory, they should take less battery or energy, and so on. And then when you are using these AI methods with people, there might be a lot of issues like data, privacy, and fairness, and things like that. Okay, so we'll see a little bit of examples of this, but this is the state of the art of AI today. The next thing which I want to talk about is chatbots or collaborative assistants. This is the context of intelligent agent that I'm going to be working in this talk. And these are systems which allow you to engage in through natural modality, through speech, image, pointing, text, whatever. And it can be working with one tool, one user or multiple users. It can be, as I said, different modes. It can be using a data source, no data source. It might just be doing chit chat, static information, or dynamic information. Okay, it's something which is telling you about weather is all continuously changing. Something just tells you about state capitals and so on is a fixed one. And then you can see other things. The most common usage of chatbot is to actually get some work done. Okay, and these systems, they are actually trying to overcome or work with three kinds of uncertainties. One is the natural language or the mode. Second is the human behavior. You ask something twice, it does not answer, you will do something. So that's an uncertainty about human behavior. And third is the task at hand. Okay? And there's a whole bunch of terminology used for them. Conversation agents, dialogue agents, virtual assistants. I'm just going to be calling them chatbots for. Okay. So if you think about the history of AI from the 50s, you can pretty much see that the history of AI is the history of chatbots. Okay, all the way from the Turing test, which some of you may know. If you are interacting with, you are behind a room, you're interacting with the two different agents. One of them might be machine, another might be human across a wall. And if you can't make a difference, then that other system is smart. That was the Turing test. And there's a whole range of progress which has happened. Sorry, it should be 2022 ChatGPT. And but you can see that progress in AI has been seen via the lens of progress in chatbots. And today they are omnipresent. You can interact with them through the web, through their various devices and your cars and so on. Okay. Any question? Anything until now? Quite clear. So now we jump into language models, and they are called large language models, foundational models, and people refer to them as ChatGPT also invariably. So this is what is happening. We have data. No matter what data you have, you are training based on certain tasks like missing word or such kind of things, and then you generate, you learn a model. artifact. And sometimes based on other data sets, you might be fine tuning it, or you might be customizing it to some new setting. And then this is called the training phase. And then you are using it on certain tasks. Okay. And then you're getting the results. So this is at a very, very high level how large language models are getting trained and then they are being used. Okay. So ChatGPT is an example of a large language model called GPT getting trained and the task being chatting. So that's pretty much what ChatGPT is doing. Okay. And this need not be the only way. You can actually have other tasks and you can have other data sets, other fine tuning and so on. So ChatGPT's release last November is considered as a turning point in the moment in technology. Lot of excitement, okay, about new use cases, whatever you can do, concerns about the social impact, renewed calls for regulation, all kinds of things. So basically, whatever was happening before, now it is gotten accelerated, okay. And the reason for that is you can take the model, you can put any task, generally speaking, generative task, whether it is generating a text, image, video, audio, whatever, and people are looking at the results and they're very excited about it. I actually gave a small spiel about what they are doing. You can find it on the university website also. Okay, so let me just give you a quick example of one generative task which one of my undergrad student did this summer. And she said, okay, let me just ask US states and their capital. Okay, very simple. It should not change, right? Capital of South Carolina, Columbia. Something as simple as that. So that is what you have. My name is Samnan. What is the capital of Alabama? From ChatGPT, the answer is Montgomery. People might know that that's correct. And then what she did was she just added the name, and usually names of people, and they are usually related with from what is their origin, or it conveys something about the demographics. Okay, and here is one example. You see the name, female name, and the system tells you not only the capital, but it tells you, okay, I'll tell you something about the civil rights and so on. So from a simple engineering principle, a system which gives you more output or less output than the right output is a faulty system. Okay. If there is anything in engineering you need to learn, it is that any engineering system which gives you more output or less output than what is the right output, there is a fault. Okay. So what's going on? And we did not change anything. Okay. And this was some date in summer. This you can find it. Sometimes you may not be able to find it. We actually went and we did a lot of other experimentation. We found that with the African American names, you would get a lot of differences, not with others. Okay, and RASA is another rule-based system. And remember, I told you about symbolic, and ChatGPT is a learning-based system. So there is a quantification of the kind of error we are getting. And this is just one example. And this is like a trivial example of state capital, right? You don't expect anything to change. It's a static data lookup, okay? And and you are getting this. Okay, so such kind of things you would find, and this has renewed interest in the research community, all overall in the society, but also into the research community. And so this talk I'm going to focus on is what has happened in the research community. Why is there some excitement? What has changed? Question?
So that answer, said that it's answering more or less than what it's supposed to respond to, right?
That's a typical system engineering.
So
Yeah.
I'm saying that
Yes.
it also could be because the Latoya is female name, like response coming from female, then Courtney is a female name too. I just
We have done elaborate experimentation on this, okay, and that is essentially directly the direction I'm going, okay. And the reason for this is when you are training, right, and you are generating something, systems, what they're doing is they are going towards stereotype. So it is about probability distribution, right? everything is connected with everyone, okay, but then you are doing a generative step and you are trying to find where is the maximum probability distribution, right? And it is going in that direction, which means that the data you are trained on or whatever you are doing. So let me give another example, okay? Go and do a Google search and say breakfast item, okay? All of a sudden, you will start seeing things made out of egg and pork products, okay? Why should that be the case? If that was the case, all the vegetarians would have died by now, okay? But that's not the case. But the data, based on the distribution it is following, right, it is doing this, okay? So whether it is good or bad is a different matter. The fact of the matter remains that it is not representative of the correct answer. You're going to, that's the crux of the problem. That's the crux of the problem. And see, the thing is, if you ask me, do you know everything about AI? My answer will be, if I'm honest, I would say, I know somewhat, and here is my error margin. Okay, where is the error margin here? You tell something and you tell confidently without an error margin. That is the problem. And this is like, it's a non-controversial domain in the sense that this is the input and this has to be the output. Okay, it's very much like if it's my photograph, do I wear a specs or not? Yes. So if that is what the answer is getting, then you should consistently get the same answer. If even you are failing in this task, what can I say in a dynamic domain? Right? That's the point. Okay. And we have more in this experiment. So student has completed her report and she's writing some things. But you'll see more example of this later. Okay, so when you come to AI task and any AI that you're generating, sorry, I should say if machine learning based AI, if you're doing, then the three common steps are having the data, building the AI, using it, and getting the results. Okay, so the LLMs can be useful in all the three stages. So they can be used, like GPT can be useful for bootstrapping data, right, generating more data at the beginning. It can be used as a way as a replacement for the AI, okay, or as a component for the AI. So for example, you are doing sentiment detection, so it can act as a part, or you can use that and along with some other thesaurus and then do this. And then it can be used as a baseline to do better than that. Okay, so even though you're not using LLM for your output, but you're using its result as a baseline for your experimentation. Okay, so three broad usage of LLMs in AI development you can do. If that's the case, so I want to talk about the particular AI task, which is of planning. So what is planning? Planning is a core task in artificial intelligence. It deals with generating plans, which are sequential decisions for going from initial state to a goal state. So for example, if I have this initial state, I have some blocks on the table, and in some configuration, I want to go into some other goal configuration. Okay, so the series of actions, the 8-step actions which I have generated, that is a plan. So how do I generate that? That is the problem of planning. Okay, and this has a broad set of applications, including robotics, in IT management. Some system is down, can I automatically bring it back up? Those kind of things. Dialogue generation, what answer should I be giving, and a series of ways. And network security, what are the different ways of attacking a system or defending a system, and such kind of things. So a broad set of applications. Okay, so this is the setting, and what we are trying to do is use LLM to serve as either an alternative or as a component of AI, which is the planning here. Okay, everyone with me? So there are some nomenclatures which are commonly used, and I want to clarify what they are. So I'm using plans, which is a series or which is a set of coordinated activities between states, and they are formally represented. You can represent them in logic. Another term which is used commonly is called workflows. Okay, and workflows involves some human actors also. Okay, so that's the difference. So in plans, you don't have manual actions, but in workflows you can have manual actions. Another term which is used is called the business process. So for example, a travel policy and the business process at the university, which will consist of a set of uh, I mean, it can consist of workflows, but usually it also consists of the business context, whether you are a supplier, you are a vendor, you are a contractor. So that kind of a context is there in a business process. And then there are web services and programs. Programs can also be considered as plans, and but they have very well execution semantics. Okay, so sometimes the terminology is used across. The way we are looking at is business process. That's a general usage, which can be implemented as workflows, programs, or web services. Okay, and that is where I'm thinking about planning and how our LLM-based planning will be used. Okay, so I'm going to be referring to plans and workflows interchangeably. Just remember that there are slight differences. Okay, and but the techniques they carry on across these areas. Okay, what do we want here? So we want to generate plans, but what is the characteristic of this? I want to generate executable plans of high quality, which are optimal, spending as little time providing the inputs. Because as I said, planning needs a lot of input in formal specification. This is the state, these are the actions. So I want to get basically, I want to get nirvana. I want to get executable plans, optimal with as little time I want to data I can give as possible. Okay. And so automated planners are there. They can generate high quality plans, but they need a lot of input. Okay. There is a high knowledge engineering cost. And then LLM based generators, right? Because they can spew out anything, I can ask them what is the best way to go to the airport. That's a plan, right? And tell you to go here, go to I-26 and so on. So that's a stereotypical plan. It will just spew out. So they're very good in giving out output, but they can be unsound. They may not be executable. They will be not optimal. There's no guarantee with it. Okay. So I like to call LLMs as your prototypical uncle or aunts, right? They have an answer for everything, but you have to verify whatever they are saying. Okay. So that's what we want to do. And we also want to do it in a manner that you preserve user data. So for example, ChatGPT came out and a bunch of engineers at Samsung, they started using it for floor planning, which is used on chips. Okay. And floor planning and chip information is highly confidential. So they were merely releasing it to OpenAI. Okay. So trust. And so this is a workflow problem, by the way, floor planning on a chip, but they were releasing information. So that's a bad idea. Okay. All right. So there are three broad approaches. We ended 310, right? Yeah. So there are three broad approaches for planning. One of them is embodied reasoning. Okay. Second is as heuristic helpers. And I'm sorry. There are three broad approaches by which LLMs are being used in planning in literature, just in a short time, okay, of 6 to 8 months. Okay, this is how the community has been using it. So you can see how quickly people are using it. So embodied reasoning, which is like robotics. So if I tell you that move the robot from here to here, do this action, and so on, right? So what we are doing is we are using the LLM as a way of generating action sequences. And if it knows about what typical actions are, raising your hand, reaching out to something, then if it has an idea about the physical world, then those plans can be useful. But many times the data may be corrupted, or it may not have the right thing. It may say you can actually lift both the object, right, both by your left hand and right hand, whereas the object can only be put in one hand, right? So there is no physical interpretation of that. LLMs are also being used as heuristic function because this is a search algorithm thing. And we are using LLMs directly as planners. Okay, so this is how in the area that we are talking about, this is used. So what I'm going to be talking about is something called a transformer, which our student Vishal, he has interned at IBM and he has been working, and a big set of group has been working on this. It is a LLM-based planner, and uh, we use Code T5, which is one of the code-based large language model. We have done some things on for fine-tuning it and running it. So I'll just talk a little bit more. And here is a demo via video, which I'll just show you. And I can't do that without showing you a small ad. So.
Amy was just another journalist in New York City, waiting for her big break. I need to run another. Hello all, I'm Vishal Pallagani, and in today's and the future scope for this line of work. Automating methods such as new or unseen uses transformer-based language capable of generating a valid plan. Thus, we believe that there needs to be a middle ground where both traditional planning approaches and learning-based approaches can be used in consensus to solve complex problems at scale. We explore one such line of work called a slow and fast planning, which makes use of plans.
Just
demand language model that is ChatGPT, a valid plan. Thus, we believe that however, there needs to be a middle ground.
So what is being shown here is this is the prompt which is given to ChatGPT. This one is encoded with some things like goal and ont B1, clear B1. So that is the description of this domain. Sorry for the bad graphics, you can't make out completely. And this is like a program. If you can see, so it's not natural language. It is, and so Code T5 basically is looking for patterns, right? So it is trained on patterns like your Java code, Python code, and so on. And here to actually give a small example, and then you ask it to generate the plan. Now there are 2-3 different ways you can do it. One is just the LLM is there, and you give the example in the prompt itself and say, give me the plan, right? Another is you fine tune it with some small data, and then you ask it to generate the plan. So those are a few small variations of how you do the training, but this is how it is actually generated. Okay, and so this is the output of what you can get. Let me just
overview. The initial step in designing Transformer is creating a planning dataset consisting of 18,000 problems of varying complexity for 4 domains, namely Bloxworld, Gripper, Hanoi, and driver log. The dataset consists of a novel prompt comprising of entities present in both domain and problem files, along with their optimal plans generated using the fast downward planning system. In our prior experimentation, it was observed that a language model pre-trained on coding problems is capable of working better with planning instances as opposed to the language models solely trained on natural language.
Then in the interest of time, I'll just explain a few key points here. So what is happening is you have a LLM, okay? You have, and it comes out with whatever is performance. It is not trained on planning problems, okay? So what we do is we give small data for fine tuning, and then so this is the small data that has been given for fine tuning, and then you get the model. Now you can actually evaluate it along 2 metrics. One is just natural language metrics. Okay, so for people who know natural language processing, NLP, so there are these metrics like BLUE and Rogel and so on. So how good is the Englishness of the plan, right? So that is one kind of evaluation. The second kind of evaluation is the domain specific. In this particular case, planning specific. So there is something called a plan validator, which can check for optimality or it can check for completeness of the plan. Okay, so those are the 2 different evaluations we can do: domain independent and domain dependent. So So understanding the capabilities of this, there's a whole bunch of things which I can tell you, but just to, the key thing which I wanted to say here was, it is not the case that any data you throw in and you will get a good performance. Okay, this has become a very it is an empirical area. Okay, we tried a bunch of models, including the GPT models here. They are codenamed Da Vinci and Code Da Vinci and so on. And we noticed that if you just do pre-trained model, okay, versus you do fine tuning with some data, fine tuning actually helps you get better plans. The best plan that we could get, right, it was about 97% of the times it was solving it and it was giving us optimal results, okay, compared to others where it was actually giving nothing. Okay, so how you do training and how you do fine tuning, what the data you use, it actually matters. So that's the key point which I wanted to say, and the paper is on arXiv. I can actually share with you, and you can look at the things. So what are we having? What we are having is, we have a reasonably good approximate planner, okay, which does very good, 96, 97% in the best domains, okay, but sometimes it does not find anything. Okay, so what do you do with someone who is good, fast, but unreliable? That's the problem. Okay, so how to use a useful but unreliable planner? That's the bigger question. So what we are doing is, I'm going to move towards the second problem project we are doing, and then we are going to use this as part of it. So what we are looking at is, how do we build planners which are fast and they on an average solve a lot of problems very well. Okay, this is inspired by, so if you remember in the beginning I said AI has this problem of being very brittle. It is very good in one domain, right, but it may not generalize to another domain. So that thing, regardless of planning or other areas, there is a whole movement of going for something called thinking fast and slow. And this is motivated by the theory, cognitive theory of Daniel Kahneman on fast and slow thinking. So what is this? This is inspired by how humans think. Okay, we have something called fast thinking, or system 1, and slow thinking, which is system 2. Don't look at someone's brain to find out where is the system. This is a way our abilities have been categorized in a conceptual framework. Okay, it is, so there are certain properties which we have. So for example, when we see someone and we can't explain what it is, but we think it is similar, yeah, I might have seen this guy. So what is happening is, we are quickly recognizing something. Okay, it is fast, it's involuntary, it's noisy, and it's constant time usually. Okay, and the slow thinking is deliberative. It is usually of better quality. Okay, and it is useful for complex decisions. So this notion of using fast and slow thinking has really caught up in computer science. And what we are doing is, we are trying to operationalize it in an architecture called SOFI. And there is more about SOFI, and this is a collaborative project which we have been doing with IBM and a whole bunch of partners. So if you want to see the team, I can actually point out this. How many of you know who is Grady Booch? You guys, you should be thrown back to programming. Grady Booch is one of the UML, one of the founders, and before that Booch notation. Okay, and a bunch of things. And there's Vishal is one of my students who has been working. So a bunch of people, right, in this area. So top-notch people in this area. And so you can check out SOFI. I'm not going to be going too detailed into it, but so the idea here is that you have a problem instance which is given to a fast solver. Okay, and it, regardless, it will find an answer. It will guess an answer. Okay, and then there is a metacognition system which tries to which has an idea about the world and so on, and it says, is this okay, or should I call a slow solver? And if it is okay, it will just give that decision out. Otherwise, it will call a slow solver and its decision will be thrown out. Okay, that's a very general thing. Notice that this is inspired by the mind, not the brain. So there are 3 levels of things. Brain is signals, right? So which is called neuroscience. Mind is cognitive architecture. And then AI is about building useful systems. So neuroscience, cognitive science, and AI. Okay. So we are using in AI, we are using cognitive models. And there are a few ways that the metacognition can work, but suffice it to say that we have in our experimental settings, right, different ways of looking at it, and the distinction is actually just shown here. Okay. Anyway, so we use Plansformer, the LLM-based planner, as a S1 solver, as a fast solver. So if you notice, again, it is fast, but it is approximate. All right. So does this matter? So what we are doing now is on the upper right-hand side, we have Plansformer as the fast solver, S1. There is a classical solver called fast downward, which we are using as a system 2. So what you notice is with this configuration, the planner on 700 problems, okay, left-hand side, you notice that SOFI, which is in the orange, right, is typically taking less time, especially on the harder problems. So if you, from the beginning, it starts, right? And because of this architecture, it takes more, there's more machinery you need. You need to store your plans previously, and then you learn from experience. I did not go into the detail of the fast and slow, but the main idea is that you solve a lot of these problems, you keep it in experience, and then you learn from them. Okay, so and that is what the metacognition is changing over time, right? It calls more of S1 in the beginning. When you don't have any experience, it goes to S2, but as you accumulate experience, it goes more to S1. Think of this as driving. When we are driving, right, in the beginning we are so careful, and all of a sudden, right, we say, okay, I know how to do this, and so we quickly take those decisions. So our experiences, right, gain, and then we are using more and more S1. The same thing is happening here. So over time, what's happening is the orange, right? It is taking lesser and lesser time, consistent on less time, especially on the harder problems, because it has gained a lot of experience. And the correctness also improves. It is not perfect, but it is improving. We can change some things in the architecture and make it perfect. But so it is a win-win in that kind of a setup. So I'm just giving you a sense of how this kind of a thing can be used, right? But it is useful, fast, but approximate. Okay. So I want to move to other things. One was on the core AI task. I want to talk about how LLMs can also be used in novel applications. So there are a couple I want to talk about. One of them is using it for financial decision support. So a lot of students have come to the campus. They want to, many of you may not have ever a credit card. Now you're thinking, oh, should I get this credit card? Okay. And should I pay my thing or minimum amount I should pay, or should I pay the full? Okay. If it is the money, if I pay less, right, the minimum, the money that is left out, maybe I can put it on stock market or brokerage account or whatever, right? So can the ChatGPT or someone can give me advice, and how good is this advice? So that's what we're trying, and Sai has been involved, but a bunch of my students, we actually started looking into this. So can it be good for personal advice? Okay, so we considered 3 products, which is credit card, credit deposit, which is CD or fixed deposit, and account balance, just the minimum account money you are getting. And we want to ask these questions. Okay, main thing is we are looking at interplay between different products and the constraints that comes in. Okay, and we looked at a bunch of other things like language, multiple LLMs, Bard and ChatGPT, excuse me, and the different languages also. This is a big table, but essentially we systematically went and had these questions. It was about certain products, and we had certain linear optimization inequality in mind when we were asking these questions. Okay. So the preliminary result is that there is a bunch of errors and so some numbers out here. BARD typically gives us accurate results, okay, with respect to numeric, but both of them were poor in numeric reasoning. LLMs are known to do poor in numeric reasoning, okay, and you can go and you can see a whole bunch of them, okay. A few things which these LLMs would do, if there was a lot of information, they would go and structure the information so that someone can understand it very well. So those kind of features also we found. So it is good. It is reasonably okay. Okay. So the next thing which I want to talk about is water. Okay, money and water. Why water? Because it's so important for everyone's living. Okay? And so the question is very simple. I want to drink water. There's bottled water, tap water, lake, and all these waters, right? Which one should I drink? It impacts the economics, environment degradation, and so on. It's a very important question. So I asked this question. I'm in South Carolina and I'm near Lake Murray. Which water should I drink? And it says that I generally recommend to drink tap water. Okay. And of course, so you can take this with any pinch of salt. Notice that it is not using any data. There's a lot of public data out there, but it is telling you based on stereotype, right? Which is, I'm not questioning. I'm just telling you that this is what the systems are doing. So people are increasingly asking questions, right? Like this from AI systems. And they may or may not use the real water data. Okay. And they are just telling you. So this can be problematic. So the opportunity is, can we bring these systems and actual data analysis together? Okay. So that's a kind of thing. This is actually a very interesting. We did a lot of experiment, both internationally and within US. Some of you may know about Flint, Michigan. It had a huge problem with the water quality. And this was like close to 7-8 years back or a little more. And at that time, we didn't have that much AI-based tools available, and people started putting web pages. You can telling that you can not drink water, but you can use it for washing or whatever. So advisory based on AI is very helpful, and we need to be very cautious about it. So, and so which choice will people use? If you put and constrain this based on budget, you only have $1 and you want to do this, right? There's a lot of interplay that is possible. So people are increasingly asking readily available decision support tools about questions, whether it is about finance, water, or health. I did not get to health, okay? But you can see a whole bunch of things. And the results can be problematic, so we need to do something better with that. So I want to end with a few points, and then I will open up for questions, any more questions you may have. The role of LLMs, right, in one's AI problem, I just want to point out, you can use this for generating a lot of data that you might need. I also showed you, you can use it as an AI or as part of assembling an AI. You can use it for evaluation, okay? LLMs can give a good approximate result. Usually an approximate result, many times they're good results. Important thing is in constant time. Okay, I'm hoping that people understand why it is constant time. Once you build a model, you deploy it, it's just one input data and process and give you the output. So this is a very important thing. It gives you in a constant time. Okay, and this can be leveraged in many places. And it has been tried in planning, recommendation, optimization, all the things which I just told you. But which one should you be using, which LLM, which configuration? It needs a lot of experimentation. There are challenges to reproducibility of results, which is very important. And you need to, it tends to tell you the output with confidence without sufficient basis. So you need to be aware of this one. And finally, just because you have an LLM and you can generate something, people say, hey, we have solved this problem. No, you have not, okay? Technology is only one part of the other pillars. You need to educate your users. You need to do research in usability, and you need to have governance, okay? What happens when something goes wrong? What if I tell you to drink tap water and you drank it and there was a harmful algal bloom and you got sick? Okay, so that has to be covered. It is like a car. I give you a car, accident happens, right? And if there was a manufacturing mistake, self-driving mistake, right? What do you do with it? So, and these things are adding and bringing, it's an exciting time to be doing AI, chatbots. We ourselves are building some next generation of chatbots, combining deep learning and symbolic methods, doing a whole bunch of things and evaluation. Okay, so I want to just leave you with this and open up for any questions.
More accuracy in your predictions is having that kind of context. So with this, like with your interpretation, that since the context knowledge is also going to be domain specific, are you going to have multiple branches of like GPT-based domain models, or could there be a universal context model that you can add on to the LLM?
So I'll just repeat the question. The question is that can there be a universal context which can be used with a universal language model? The thing is, if there is a universal context, then it can be put as data, and then a language model can use it, right? So, in at least in hope or aspiration, we can think about that. In practicality, it is not there, and that is because of number of reasons. Okay, and they are all practical reasons. For example, you don't get all the data to train language models. It's not available. You only have open data. Everyone is training or using Wikipedia. No one wants to put their own data. Data is one of those things where you want to use everyone else's but don't want to publish your own. Okay, so that's number one challenge. Number two challenge is not everything worth learning is represented in data. Okay, or data which is computable. How many things which we are thinking we are writing? That's why there is something called enterprise memory. Okay, not everything which is thought of is written. Not everything which is written is accessible, right? And then of course, whatever you are doing, right? There is all these cost. Okay? So that's the practical reason. So theoretically yes, but practically no. Any other question, comment?